Hello, fellow explorers of the atmosphere and the digital frontier. I'm Ernis, your guide through today's mind-blowing journey into the world of air quality monitoring. Imagine for a moment that we're not just breathing in air, but swimming in an ocean of data, invisible particles, fluctuating temperatures, and whispers of pollutants all around us. It's this invisible world that we're going to illuminate today, and the insights are absolutely essential for our health and the health of our planet. The question of how to best understand and interact with this data is absolutely captivating. Let me take you through a memory palace I've constructed to help us understand this. Picture a gleaming, futuristic cityscape, where each building represents a different element of this research. Today, we're diving into a fascinating paper titled LLM-enhanced Air Quality Monitoring Interface via Model Context Protocol. Now, I know what you're thinking. LLM? MCP? Sounds like alphabet soup, but trust me, it's a delicious soup, packed with innovation. This paper asks a critical question. How can we make air quality monitoring more accessible and reliable for everyone, not just scientists and experts? The core of the problem is this: traditional air quality monitoring systems are often clunky, expensive, and difficult to understand. You get charts, graphs, and numbers that might as well be written in ancient Martian. But what if we could talk to our air? What if we could ask, hey, what's the air quality like right now, and should I be worried? That's where large language models, or LLMs, come in. Think of LLMs as super smart parrots that can translate complex data into plain English. They can summarize information, answer questions, and even provide recommendations. Sounds great, right? But there's a catch. LLMs are notorious for hallucinations, making stuff up. The air is perfect today. Enjoy the sunshine, even if there's a cloud of smog right outside your window. That's where the Model Context Protocol, or MCP, enters the scene. MCP is like a set of guardrails for the LLM, ensuring it sticks to the facts and doesn't go off on a wild, fact-free tangent. We want our LLM to be a reliable scientist, not a conspiracy theorist. Let's step into our memory palace. The first stop is the sensor data acquisition room. Visualize a high-tech lab filled with sensors humming and blinking, constantly collecting data on temperature, humidity, and those pesky particulate matters. In PM10, these sensors are like our air's taste buds, constantly sampling the environment and sending signals back to headquarters. Now, imagine stepping into a grand library filled with stacks of books representing our air. Each book holds a dazzling secret about air quality. Well, that's exactly what we're about to discover together. Next, we enter the back-end service room. This is where all the data gets organized and processed. The authors used a Django-based back-end, which is like the central nervous system of our system, ensuring everything runs smoothly and securely. From there, we move to the database vault. Picture a massive, secure vault filled with rows upon rows of data, meticulously stored and protected. This is where the historical data lives, allowing us to track trends and identify potential problems. Then, we arrive at the front-end interface room. This is where the magic happens. Visualize a sleek, user-friendly dashboard with interactive charts, graphs, and maps. This is how we, as users, can visualize the data and interact with the system. Now, I want you to join me in visualizing something remarkable. Imagine you're standing at the edge of our atmosphere, looking down at Earth, a swirling, vibrant blue marble. What do you see? What patterns emerge as you observe this landscape? This is precisely what the researchers uncovered when they. The most groundbreaking part of this research is the AI functional module. The researchers used the DeepSeek v3.0324 model, which is like the brain of our system. The system acts as an intelligent assistant for the AMI system, with the primary responsibility of assisting the currently logged-in user and strictly adhering to permission constraints when calling tools, prohibiting access to or modification of other users' information. Precisely, and the authors didn't stop there. They showed that this architecture generalizes well to other tasks, like English constituency parsing. That's where the model tries to understand the grammatical structure of a sentence. And finally, we reach the MCP server room. This is the heart of the system, where the LLM interacts with the backend using the Model Context Protocol. Think of it as a secure communication channel, ensuring that the LLM gets the right information at the right time, without making up any silly stories. Now, some of you might be thinking, okay, Ernie, this all sounds great in theory, but does it actually work? Well, the authors put their system to the test, and the results were impressive. They conducted an expert evaluation, and the results demonstrated high factual accuracy, completeness, and minimal hallucinations, on a scale of 5. These results highlight the potential of combining LLMs with standardized tool protocols to create reliable, secure, and user-friendly interfaces for real-time environmental monitoring. Fine, yeah, I guess. Look, the point is, this paper is a big deal. It offers a promising approach to making air quality monitoring more accessible and reliable for everyone. By combining the power of LLMs with the security of MCP, we can create systems that are not only informative but also trustworthy. So, what's the big picture here? This research takes us one step closer to a future where everyone can understand and interact with their environment in a meaningful way. Imagine a world where air quality information is readily available, empowering individuals to make informed decisions about their health and well-being. That's a future worth fighting for. And that, my friends, brings us to the end of our journey through this fascinating paper. I hope you enjoyed our exploration of the LLM-enhanced air quality monitoring interface. Now, I encourage you to dive deeper into this topic. Read the full paper, explore the related research, and let your curiosity guide you. The universe of knowledge awaits. Until next time, keep exploring, keep questioning, and keep breathing that, hopefully clean air.